Good evening, ladies and gentlemen. If you can hear me, just go to the chat box and say yes, so that I will know that we are together. And hear me, say yes, the chat box. If you can hear me, okay. I've seen a good number of yes. So I want us to, without wasting time, to look at this particular problem. I hope you can see the screen. Can you see the screen? Can you see the screen? Okay. If you can see the screen, let me know. I want us to look at this particular question. We have done resolution of forces. We can resolve forces, two or more forces. And the question say here, three forces act at a point in the XY plane. F1 is 10 Newton at 30 degrees to the positive x-axis. F2 is 15 Newton at 120 degrees to the positive x-axis. F3, 8 Newton at 210 degrees to the positive x. First question is resolve the forces into x and y components. 2, find the resultant force in the vector form. 3, determine the magnitude and direction of the resultant. So if you can see this question, can you see the question? Yes, I can hear you. Any challenge? Any challenge? I can hear you. Can you hear me very well? Any challenge? Just point out where the challenge is. So what is the challenge? Okay, no, I can't hear you. You can adjust the volume of your phone or your device. Adjust the volume of your device, please. Okay, so that's the question. Three forces act at a point in the XY plane. F1 is equal to 10 Newton at 30 degrees to the positive x-axis. F2, 15 Newton at 120 degrees to the positive x-axis. And F3, 8 Newton at 210 degrees to the positive x-axis. The first question is resolve the forces into x and y components. 2, find the resultant force in the vector form. 3, determine the magnitude and direction of the resultant. So the first thing is you need to resolve them in the x and the y. And I explained that while resolving on the x-axis is cos theta, on the y-axis is f sine theta. So the first force, which is F1, the second force, F2, the third force, F3, can be resolved into x-axis. So we are not seeing the question clear. Your question is not clear. But if you can hear me, that is the most important thing. Let me repeat the question again. If you can jot it down. Three forces act at a point. Three forces act at a point in the xy plane. Three forces act at a point in the xy plane. F1 equal to 10 Newton at 30 degrees. F1 equal to 10 Newton at 30 degrees to the positive x-axis. F2 equal to 15 Newton at 120 degrees to the positive x-axis. And F3, 8 Newton at 210 degrees to the positive x-axis. Then we are to resolve the forces into x and y components. That is number 1. 2, find the resultant force in the vector form. And 3, determine the magnitude and direction of the resultant. So the three forces, we first of all resolve them into x. For example, F1, we can resolve it into 10, the force there is 10 Newton cos 30. Then F2 will be 15 Newton cos 120, and F3 will be 8 Newton cos 210. And by the time you evaluate this, you have the values. That is the value of cos 30 multiplied by 10 will give us 8.66. The value of cos 120 times 15 will give us minus 7.5. Then the value of cos 210 times 8 will give us minus 6.93. So for the y component, we now have 10 sine 30. I explained why, if you are resolving on the y-axis, is sine. 10 sine 30, and if you get the value of sine 30 multiplied by 10, it gives you 5. Then the second force is 15 sine 120, and if you get the value, it is 12.99. Then the third force, which is 8, that will be 8 sine 210, and if you get the value of sine 210 multiplied by 8, gives you minus 4. So the next, that is, we are done with the first part of it. The second part is the resultant. The Rx 8.6 plus minus 7.5. I hope you know where we're getting these values. That is for F1 is 8.66. For F2, 7.5. For F3, we have minus 6. So by the time you sum these three forces, you have minus 5.77. Then for the Ry, that's the resultant on the y component, you sum the 5, 4, and plus minus is minus 0.99. So by the time we will take the modulus, magnitudes, we take the square root of those values, minus 5.77 plus 13.99. If you square those values and take the square root, we'll have 15.13 Newton. I hope you guys with me. So the next question is, the position vector of a particle is r of t. We know that r is the position vector. T raised to power 3 I minus 4t squared j plus 2t k. Find the velocity vector. Find the acceleration vector as number 2. And number 3, determine the angle between the velocity and the acceleration at t equal to 1. Remember, this is a case of differentiation. We know that velocity is the rate of change of displacements, and that displacement is our position vector. So by the time you differentiate r of t, we now have 3t raised to power 2. We all know how to differentiate, minus 8t plus 2. So by the time we integrate those unit vectors, we now have 3t squared I minus 8tj plus 2k. And that is the velocity vector. What of acceleration? By the time we differentiate the velocity, that is, acceleration is the rate of change of acceleration, the rate of change of uh, velocity. So by the time we differentiate the velocity, we now have 60 minus 8. So incorporating the unit vector, will now have 60i minus 8j. Then at the point where t is equal to 1, at the point where t is equal to 1, we'll substitute the value of t into the velocity component and the acceleration component. And by the time we substitute that, we'll now have, for the velocity component, we'll have 3i minus 8j plus 2k. For the acceleration component, we'll have 6i minus 8j. So for us, if you look at number 3, part 3 of the question, determine the angle between the velocity and acceleration at this point, t equal to 1. We appeal to dot products. So by the time we do the dot products, remember, in dot products, multiply by 6i, I is 1, plus, for the j, we have minus 8 times minus 8, dot j is 1. Then for the k, in the acceleration component is 0, so we'll have 2 times 0, and that will vanish. So if you add 18 plus 64, that gives you 82. So the modulus of V is 3 square plus minus 8 square plus 2 square. So by the time you evaluate those figures, we have 8.77. Then for the acceleration components, we also have 6 square plus minus 8 square, and that gives us 10. Remember, for the angle, we have cos theta equal to the dot product divided by the dots, the modulus divided by the dots products, and that gives us 82 by the value we got from the modulus of V and the value we got from the modulus of A, and that gives us the angle to be 20.3 degrees. So I want you guys to look at this. In vectors, we can do dots product, we can do cross products, look at the identities, we can find angle between two vectors. And for you to find angle between two vectors, you need to know the dot product and the magnitude of the vectors. Of course, we know that, for example, if you have vector A and B, the formula is A dot B equal to modulus of A modulus of B cos theta. So it means you need to find A dot B, you need to find modulus of A modulus of B, and then make cos theta the subject, and that solves the problem. And this is a similar thing we have looked at here. We are asked to look at the angle between the velocity and the acceleration at t equal to 1. And at that point, we're able to evaluate, and we got this 3I minus aj plus 2k. That is for velocity. For acceleration, we have 6I minus aj. So we have to do dot product. That is v dot a. And we got 82. And then the magnitude of v got 8.77. Magnitude of a got 10. So a dot cos theta becomes v dot a, which is 82, divided by the magnitude of the two, and that is where we arrive at 20.3. You can look at other things, but I don't tend to take much of your time, but you can look at this. So if there's any question, you can ask me on the chat box. Any question? Okay, somebody is asking the question, please. So let me read the question again for the last time. If you are ready, I'm reading it. 3 forces act at a point in the xy plane, and F1 is equal to 10 Newton at 30 degrees to the positive x-axis. F2 is equal to 15 Newton at 120 degrees to the positive x-axis, and F3 is 8 Newton at 210 to the positive x-axis. I. Resolve the forces into x and y components. 2. Find the resultant force in the vector form. 3. Determine the magnitude and the direction of the resultant. That is those question 2. The position vector of a particle is arrow of t equal to t square I minus 4t square j plus 2t k. Find the velocity vector. 2. Find the acceleration vector. 3. Determine the angle between velocity and acceleration at t equals to 1. So, these are the questions. Somebody asks, is there any other challenge? Is the area we should focus on for tomorrow? It's a funny question. So if there's any other challenge, you let me know. If there's no challenge, we can call it a day.